Hey guys, video about double displacement reactions. Double displacement reactions. Let's take a look at what this looks like in terms of letters and make some sense for it. And then I'm going to tell you how to use your activity series. If you don't have an activity series, you need to pick one up. You've already seen my single displacement video, so you need to pick one up. Okay, we're looking at the bottom of the activity series where it says solubility of compounds for double displacement reactions. This is the expression that we will use for double displacement. It takes AB, which are your first two ions, okay, plus CD, will give you AD plus BC. AD plus BC. Okay? It looks like I couldn't get the light off of that. I think it's actually my lighting that actually should be down here instead of my other lighting. So, this is going to be what we use for double displacement reactions. A couple things you need to know about your table. Okay? That there's two letters on your table. There's an I, an S. There's actually another one. Lowercase s and big S. Insoluble. Insoluble means that it forms a precipitate. Okay? So let me write that down. I'll write down what it is first. Insoluble. Bad handwriting. Forms a precipitate. A solid. So when you do these reactions, if you ever form something that is insoluble according to the solubility, then it's going to form a solid. And we're going to see some of these during class as demonstrations as we move forward. But those are going to be the insoluble ones. S means soluble. Sorry about the jump. That is one word. Okay, I have a crack there from the concrete. So, soluble, okay? SS means slightly soluble. Something that is soluble is something that forms an aqueous solution. That means it dissolves in water. Let me say that again. If it is soluble, it forms an aqueous solution. The letters for aqueous is AQ. So, if something is slightly soluble, I'm never going to give you that one ever on a test. But if we run into it at all, it would be aqueous. Just use aqueous. It'll be all right. I'm not really worried about it. So, as we look at this, we're always going to have to tell, is it solid, liquid, gas, or aqueous? Okay, and this will help you determine if it's a solid or aqueous. So, let's look at some examples. This one will not be as long. I'm sorry for the length of the other one. I had a lot of content to get through, and I want to clear up any misconceptions. So, just a second, this spot. Alright, hopefully we don't run out of room on this one. I have sodium hydroxide. This is an aqueous solution. Okay? I know it's aqueous because when you look at the chart, I'll show it to you one time today, or during this lecture. At the very bottom, you will see sodium on the left-hand side. It's towards the bottom, third one from the bottom. You find hydroxide, which is right in the middle, It has an S where they meet. That means that it is soluble. That means it's aqueous. Same thing with silver nitrate. AQ. Okay? Should have wrote it down at the bottom. Hopefully that shadow helps you see it. So, now my lighting's all messed up. So, what do we get? Well, we take the first one and the last one and put it together. A and D and put it together. So that's sodium and nitrate. You crisscross that. You're always going to have to crisscross, 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 crisscross. Sodium and nitrate will give you 1-to-1 ratio, NaNO3, okay, plus the middle two. Remember, this is A, B, plus C, D will give me AD, sodium nitrate, plus CB, silver hydroxide. If you follow those steps, you cannot go wrong, okay? And unlike single displacement, there aren't a million different ways to do this, okay? There's one way to do it. You're going to get it right if you do this, okay? So CB, silver hydroxide. Silver plus 1, hydroxide is one you have memorized, minus 1, so you crisscross, silver hydroxide. Are you done? So close. If you can do this, you have almost mastered all of double displacement. So this video is not going to take 20 minutes like the other one, I promise you. Last thing you have to do is you have to determine, is it aqueous, solid, liquid, or gas? But it's not going to be liquid or gas, because that's not the point of these. So is it solid or is it aqueous? Okay? So you look on your chart, you're going to find sodium nitrate is going to be aqueous. And silver hydroxide, Mr. Ullery doesn't have memorized. So he would look at his chart, go down to silver, over to a hydroxide, and you will see, coincidentally enough, that's the only one that doesn't really have anything listed in terms of an I or an S. Okay, it just has a dash. And the dash means doesn't exist. Now, can you realistically form this into a solution? Yes, you can. Okay, can you form a solid out of it? No, you can't. Okay, but you can form it into a solution. You can put ions together. It's foolishness ever to have a dash, but it is what it is. So I'm going to put aqueous. Hopefully my next example does not have that. I apologize for that. But if it was an I would just put solid. If it's an S, I put aqueous. That's it. That's the only difference. Okay? So let's take a look at another example.